Hi, this is Mayo. I'm going to be taking you through my final project for the class. And the workflow I developed is automated planimetric feature extraction from historic documents. And I chose this workflow or tried to develop this workflow because at our company we work with this information quite a bit. We often have a site that has been around since the early 1800s, and we have to get a good picture of how that site has changed over time, how the features have changed over time, and really we want an accurate depiction of how the entire site and the vicinity has evolved. And really we have access to numerous reports, numerous documents, and we review quite a bit of information. And these documents can have planimetric features such as footprints, railroad tracks, tanks and storage areas, and also wetland boundaries and other sort of sensitive receptor or environmental outlines or boundaries. The maps themselves, while the reports might date back maybe to the 60s, there are also, we may be able to apply this to other images that date back earlier than that. And the point is that there's a lot of this information, many figures. Each figure might have a little bit different information, and it's important to be able to get through that information, extract the features efficiently and accurately. And so for the project, my technical strategy is outlined here. So we start with a series of images, and I've outlined 3 here. They need to be pre-processed, and I used ArcGIS for that. So they need to all be similarly contrast stretched. They need to have kind of the same, I guess you'd say spectral properties, but the same digital numbers or similar digital numbers for this to be an efficient process. And then I take it through Feature Analyst using an unsupervised learning routine. That will provide me with polygonal outlines for the areas of interest. And then using ET GeoWizards, which is another third-party ArcGIS extension, I'm able to extract the center lines from those. And once those center lines are extracted, we can post-process them and make them more accurate. But as I'll say a little later, I think the end process here is sufficient for these purposes. So the software we're dealing with are Adobe, because we're often working with scans of images, ArcGIS, Feature Analyst, ET GeoWizards, and then I'll talk a little bit about some of the automation at the end in Python. Now, from here down, we're working within the ArcGIS and ArcMap environments. And so the table here outlines really the process. We go from PDF to image, we go to a resampled stretched image, classified document, polygonal features, extracting the specific class from that polygon after the unsupervised classification, creating the center lines, cleaning the polylines as best we can, and leading to an automation process that we can apply to numerous images. And the first step is pre-processing. For the project, I used 4 images. The first step is to bring them into geographic rectification. This particular project's in New Jersey. And so I like to track how well the image comes in with the root mean square error in feet. And you can see that it varies a bit, but we're well under 4 feet, and we could probably improve that a little bit too. And as we know, and if you've ever dealt with scanned images, there can be quite a few interesting ways that it was scanned in, and the clarity can vary. So you can see that in some instances, a second order polynomial second order polynomial interpolation was applied. A couple that only required the first order. So that can vary as well. So it's important that the pre-processing is done to within a tolerance of your accuracy, within the tolerance of your accuracy. And so what you see here is the resulting unsupervised classification. And what we've done was we've used Feature Analyst, applied a histogram equalization contrast stretch, used a square input representation. We aggregated, this is a default, but it seemed to work well for my purposes, that we we aggregated areas that are a minimum of 60 square feet. The resulting polygon coverage was ones, which are the green, and zeros, which are the negative space. And then the feature extraction file, the model file from Feature Analyst, was exported to a tool, and I'll show you how, and I'll show you why that was, because we bring it into Model Builder eventually. And after the polygon was developed, we were able to find the center lines here using ET GeoWizards, and as you can see, it tracks really well. There are some areas that aren't going to be included in the final. I should note that the final product for this is going to be a polygon feature that we're going to get out of this polyline. I think, you know, the final, this is not the final product. I think the purpose is to get a digital coverage that that was easily manipulated into getting our final polygon for our buildings, our features, and things like that, or final polyline. I performed a sensitivity analysis to see what post-processing on the polylines I could do to clean it up. There's dangling, you know, we could perform a dangling node clean, other sorts of processes. We could generalize or densify the vertices in the polyline, and really I found that those weren't really adding to the accuracy, and at some points they were actually diminishing it. So when you generalize or you lose when you lose vertices, you could really, you know, miss maybe a building corner here or similar things. Now, the best way I thought to get this process automated was to use Model Builder, which is an ArcGIS tool. The first portion here is my imported Feature Analyst unsupervised extraction. After that, I performed a selection of the polygon layer that was the actual line work, and this is these are intermediates here, intermediate files, and this is the selection class, and I basically use this ET GeoWizard center line to get to the output, and I've made the input and the output parameters, input and output sections parameters, so when the dialog box opens, it's asking for that. This model can be exported to Python, and I've done that. It can also, you can also batch process this, and this window gives you the batch processing. So if you're good with Python, you can automate many maps using loops. If you don't want to use Python, you can actually just use the batch processing here in the Model Builder window. Now, I think, as I was trying to say before, the end point of this workflow is to provide a functional polyline feature that is extracted from a static scanned image. That feature can then be processed either as a final polyline or a final polygon that has your attributes, a building number, a building area, a feature number, maybe it's a tank area. You can identify all that information in the final attribute table. And I found that in this workflow, the polyline coverage did require minimal edits at the scales at which I'm working. I think if you need to really get into the in closer and work with larger scales, then you need to probably process it a little bit more. But at scales I'm looking at, which are 1 inch equals 100, 1 inch equals 200, the polylines are fine. And part of the final analysis, I was able to build this model that can be consumed into a Python script and automated. I think the point here is that we're successful in working with 4 images, 4 completely different site plans from 4 different reports, and extract the meaningful information from all of these, and I think it worked pretty well. And that's it. Thanks for listening. I appreciate the time. This was this was something I really wanted to do, and I think it came out. I think it came out pretty well. So this is my contact information. If you've got any questions, how you can contact me through this email. Thank you very much.